Felix here to share information with us about FHIR to HL7v2 conversion. So I will go ahead and turn it over to Carlos.
All right, good afternoon, and hi from Florida in the United States. I'm going to be talking about a new FHIR to HL7v2 conversion library we created as part of the CDC ReportStream program. And that can help you with incremental modernization of your systems and your goal to get into FHIR support. First, who we are. My name is Carlos Felix, like I mentioned. I'm an architect and software engineer with Agile 6 applications. I'm the designer and developer for this library, and I'm going to be talking about it today, later in the presentation. My coworker, Patricia Peroso, was not able to be here today, but she's a software engineer with the US Digital Service, and she's also a developer and product owner for this library. So we both work for the CDC, which is the National Public Health Agency for the United States. So before we get to the library, I want to give you a little bit of history on how we got there, because there are reasons that we actually chose to create this library for what use in our system. So this effort is part of the CDC ReportStream program, which is part of the CDC Prime effort for pandemic readiness. So ReportStream is a free open source electronic lab reporting platform in the US, and it aggregates reportable disease test results from reporting entities like testing facilities, data aggregators, community organizations, which include schools and the likes, even manufacturers that want to supply test results as well. So pretty much anyone that needs to meet the reporting requirements in the US. We then deliver that data to public health departments that have jurisdiction over the data. So it's pretty much a routing system for public health data. But supporting this wide range of entities comes with challenges, and our major challenge here is to meet public health where they are. So what does that mean? Well, different entities have different levels of technological and knowledge maturity. So for example, we can have a hospital that's reporting, and they have an EHR system, and they can do automated reporting to us, maybe even using HL7v2. However, you may have a doctor's office that also needs to be doing reporting, but all they can do is maybe have an Excel sheet and report it that way. So there's a big difference between entities on how they can report and what they can do, and the effort that they can put into the reporting process. So that all leads to our goal to speed up the process of onboarding new data models and customers. And how do we get there? Well, we have to have a system that will support various data formats, CSV, HL7v2, FHIR, yes, CSV, comma separated, which is quite common right now. We need to support different levels of data quality. So some places may give you a lot of data and it's accurate. Some places may be very little or incorrect, and we have to fix that as well. We have to route that data to the public health agencies based on jurisdictional rules and quality gates that they provide. And of course, to deliver that data, we have to support various data transports, because these public agencies are different. They have different technology. So we have to support things like REST, SOAP, SFTP, and so on. All of this is to support incremental modernization of healthcare by being able, again, to meet public health where they are and give them a chance to incrementally get to where they need to be, especially in the road to FHIR. So that's going to take a while for some entities to get there. So how do we support this with ReportStream? So let's look back at ReportStream, what I call ReportStream version 1 during the COVID pandemic. So we had a huge influx of reportable test results that were being submitted via paper and fax. And yes, that picture that you see there is a real picture of test results. So the goal was to reduce this burdensome manual process. And that's a challenge that our friends in the US Digital Service took on and succeeded. How was this accomplished? Well, ReportStream version 1. So the system converts HL7v2 and CSV data and normalizes it to an internal CSV format. So normalizing the data into one format allowed us to enrich and route the data regardless of the original input format. Of course, there were limitations, but the system was working as designed for the COVID pandemic, but only supported one reportable condition per report. So we have a system, we can get the data, we can get it through, perfect, works. However, we need to look into now pandemic readiness. So we had a lot of data, a wide range of data, different qualities, variations in the data. Lots of hard coding had to happen, lots of special configurations have to happen to get the data where it needed to go. So we had to, again, meet public health where they were. So we actually had to bend a few things to get the data to a point that it could be delivered to public health in the correct manner. This included, of course, a conversion from the internal CSV format back to HL7v2. So we actually used the HAPI HL7v2 library for that, but because, again, all the data variations, there was a lot of hard coding to be done to get it to the point to send it out. Again, the system was working great. It did what it had to do, but we now had to look into pandemic readiness. So move forward to ReportStream v2. So now we're looking into how we can make ReportStream be pandemic ready and make it into a flexible platform that can support all ELR reportable conditions. So to do that, we created this brand new data pipeline that uses FHIR as its internal format. So that by itself provided a huge amount of flexibility because we can now support multiple reportable conditions, but we can also support any other type of ELR and other trigger events and even other message types. So again, we've taken multiple data formats. In this case is HL7v2 and FHIR, and store the data as FHIR internally, which means we have to do functionally lossless conversion from HL7v2 to FHIR. And we use the Linux for Health library in this case to do that conversion from HL7 to v2. So we have this internal FHIR data format that now we can do all the routing and all the data validation and any type of filling the data gaps and so on. The FHIR transformation that we have in the system is the one that will enrich this data to fill in those gaps, so we can take a FHIR bundle that we have internally and then make changes to the data. We do that a lot for like long codes and filling out the correct descriptions and the correct SNOMED codes. So we actually look at the data to fix all those pieces. So that's kind of one of the major gains there. Because we're using FHIR, we now can use FHIR Path. So I mentioned before in version 1, we were hard coding a lot of the filters and a lot of the routing, but now we don't have to. Now we have FHIR Path, which is extremely, extremely powerful. And we don't have to hard code any of those things. It's all configurable thanks to FHIR Path. So we still deliver public health agencies. We still deliver to the public health agencies using the various transports again, because that's what they support, SFTP, REST, and so on and so on. But we now have a new problem. Now we have a system where we have an internal FHIR format, but we need to convert it to HL7v2 because right now that's the preferred format for the public health agencies. And hence we get to this library that we created. There was no existing library or service that could support our conversion requirements. So we built it. So now let me talk about the library we created. So in simple terms, it just extracts a value using FHIR Path and assigns it to one or more HL7 fields. That's really at the very, very high level what it does. It's a lot more complicated like that because it's really flexible and allows for a lot. So, and I'll go through some of that as we go through here. It is Java-based. It's written in Kotlin, which is the language that ReportStream uses. It uses the Java HAPI FHIR and the HAPI HL7v2 libraries, which has been great. And I appreciate all the effort those teams have put into it. It just made it so much easier. Converts one HAPI FHIR bundle to a HAPI HL7v2 message. And it's all configuration driven. Remember I mentioned ReportStream v1 was a lot of hard coding. We made it a point that there should be no hard coding here of any kind. Everything had to be configurable. And I think we were successful with that. I'm going to be talking about the initial version, what I call version 0.1, which supports only FHIR R4 to HL7, ORU R01, version 2.5.1. However, the new version supports pretty much any message type and version that the HAPI HL7v2 library supports. But I'm going to be talking about this one here, just to keep it simple. All configuration is read from a text-based YAML file or passing as an object. And the whole deal of the object is something we want to do too. We store the configuration something like in a database, and then we can pass it into this converter library. And of course, this is thread safe. So I'm going to go over just a few high-level features of the library. I don't have time to go over all of it, but just to give you an idea of what it can do. So this library is flexible, and it does it through its extensibility and reusability. So we have top-level schemas that define the HL7v2 message type and version that's going to be output by the library. And then it has a list of elements that define either segments or fields, whatever you need in there. But there's also child-level schemas that define a set of elements, which can be, again, segments or fields. But the key here is this child-level schemas are reusable. So you can create a child-level schema for like the field type CWE, and you can reuse it in multiple places. So that makes it easier to write schemas because you can reuse the configuration as you go through the different fields that use the same types. In the end here, more flexibility as the top-level schema can be extended. And we use this a lot because we define a top-level ORU R01 that's based on the HL7v2 to FHIR mappings. And then we define new schemas. We extend it to make sure that we can support a public health depending on the changes in the data that they need. Another feature that this library has is using FHIR Path expressions for many things, including extraction. And that has been, I think, is the biggest feature that comes out of the box and has made it so much flexible. We did have to extend FHIR Path a little bit, adding a few functions, but nothing much, just functions to manipulate and validate phone numbers and IDs, just to make it easier in the configuration. So it's not too much configuration in there, and splitting functions as well. Element definitions, we can do things like setting root location. For those that are used to FHIR Path, you can set the resource, the %resource constant there, and use that. Conditionals to define if the element is going to be evaluated, a list of FHIR Path expressions to extract values. And I say a list because you can have a list, but the first one wins. So the first non-empty value wins. And that allows you to set up like default values to set on those fields. And then you can, of course, set, what am I going to do with this? Where am I going to put it in the HL7v2 message? Or you can even iterate through FHIR collections to do repetitions, which I'm going to talk about right now. So repetitions are a big feature we had to add. It actually takes a FHIR Path expression, which it will evaluate to a collection, and then you can iterate through it like an array, and then create repeatable segments or fields, whatever you need in the HL7v2. So finally here, the last one I'm going to mention is constants. So we added constants to the configuration so we can reuse this schema, so we can make changes to it, so we can make it easy to write even HL7 specs and FHIR Path statements. They're all inherited as you go through. You have the top-level schema. All the constants there can be seen throughout the entire configuration. Or if you have an element with a constant, it can only be seen there, or a child schema. So all these rules are listed in the documentation online and the repo, and you can go through it. But I just wanted to give you like a very, very high level of some of the features that this library has. One of the key things we did was to use the HL7v2 FHIR mapping that was developed by HL7 in our system, because we wanted to have an FHIR bundle format that was standard so other people could use. And this was actually a big deal because we do have a sister project called Simple Report that was able to go from CSV all the way to FHIR very easily by following this format. I know I'm running out of time here. I just wanted to mention there's more features in version 1 here. those features are already developed in the ReportStream repo. They're just not in the library repo. So all that is actually in production and being used. So hopefully we'll move that soon here. Here's the links for the repo with documentations, just to give you an idea where to find things. And I included a link to the ReportStream Prime Router as well. Finally, contacted me during DevDays in the app or through my email. But if you get a chance, contact ReportStream at cdc.gov with any questions, feature requests, if how you use the library. We need to know the interest in the library so we can actually assign the right people to work and migrate all the code to that library. And with that, I'm going to switch to questions.
Carlos, any questions from within the room? Got one right here.
Mm-hmm.
Hi, question. Mostly when you're mapping from FHIR to version 2, one of the key problems is trying to detect the trigger event, but obviously that's not really the issue in your case. But still, given your experience with this directional mapping from FHIR to V2, what in your mind are the main difficulties in the mapping itself? Is everything covered by your solution? But what's your main experiences towards what are the main problems here?
Yes, so the main problem we had, and this is based on our use case, the main problem we have is even going from HL7, which is, it tends to be popular and us receiving that format, to FHIR and back to HL7, the public health departments want all the data that was sent. So we had to do lossless conversion. So we had a huge amount of effort going from HL7 to FHIR because it's configuration driven. We had to add beyond the data that's in the HL7v2 to FHIR mapping. We had to add extensions to have extra data that was missing or that we really needed, even if sometimes it doesn't make any sense because FHIR tells you what the whole story is. We needed to have very specific pieces of data carry over. So that was one of the bigger challenges. That included even the trigger event, like you mentioned. So we had to have the trigger event in there, although that's specified by the mapping. So that was kind of easy, that was in there. But the challenge was to have functionally lossless conversion from one point to the other. And I think we achieved that with the samples that we have. And it's achievable because all you need is to just increase the amount of configuration you have in the libraries for the conversion. But it takes a lot of effort. Sometimes you get crappy data, sometimes you get good data, and you have to account for all that.
Any other questions from? Oh, any other questions from within the room? If not, Carlos, thank you very much for your time, and everyone have a great day. Thank you.